Hi, today we are going to talk about how to find the electric potential or the voltage, if you don't know what is the meaning of the electric potential, at some arbitrary point in the free space. Okay, the methodology of finding the electric potential can be understood when we fathom the relationship between the electric field and the potential. Okay, in this case, the electric potential between these 2 points can be found by the integration of the electric field along this path, okay? It could be done by the formula that I am going to write right now. As you see in this equation, the voltage between P2 and P1, okay, the voltage between P2 and P1 can be found when we integrate the electrical field along the path between P2 and P1. Okay, and regarding to the electric field, how can we determine the electric field at this point, at this arbitrary point P in the free space? This can be found when we consider Coulomb's law. Coulomb's law equation is we can find the electric field at the arbitrary point P when we know the magnitude of the charge Q and when we know the distance between P and Q, the charge. Okay, now let's insert the right hand side of this equation in the place of E in this equation. Now and of course I don't want to forget the negative sign, and this is representing the voltage at P or the potential at P. And now regarding to this path DL, this path represents the path of the electric field between the charge Q and the point P. Okay, now this path is going to be radial. The path of the electric field is going to be radial between the charge and the point directly, and we denote for the path by R vector. Okay, and this R vector now this is the path, so that assign L for R. So except for L, put R. I mean, instead for L, put R. Now the only thing needed to be determined is deciding the range of the integral, and the potential is specified as a difference for all time. There is no absolute potential. So that we need to find a reference to measure the potential with respect to, for example, the potential at some arbitrary location R is written like this: VR minus VO, where O is an arbitrary reference that we measure the potential at R with respect to. The optimal selection for the reference is indeed yielding 0. So we want to find the reference where the voltage at O is equal to 0. And according to the fact that electric field is following the direction of decreasing of electric potential, and to articulate this differently, the electric field is moving from regions of higher potential to regions at lower potential. so that the region at, for example, at this point, okay, is higher than the potential. I mean, the potential at this point, let's say this point P1, is higher than this point P. And accordingly, as the field is moving until infinity, at infinity, okay, at infinity, we have the lowest potential, which is 0. So the reference is infinity. So due to this, we are going to integrate between infinity, let me clear this more, infinity, okay, which is the reference, and R, which is the distance between Q and P, or where the arbitrary point P exists. Now, we are going to do this integration with respect to dr. Okay, I'm going to write this on a new paper. Now, let's start integration with respect to r. This power of r is going to be reduced from r squared to r. So, and assign these two ranges to r in this formula, and the answer is going to be, anyways, these negative signs are going to cancel each out. So, and this is the final equation that we are going to utilize in order to find the electric potential at an arbitrary point in the free space. This equation is valid for all conditions in the free space. And that's the end for this video. See you.